Okay, now 8-bit representation. So first 127 symbols of our Unicode are, first 127 symbols of our Unicode are ASCIIs, correct? They require how many bits? 7 bits. But we will still pad 1 bit with 0 because everything that can be represented in a computer is a byte. If you go to the lowest granular unit of memory, it is byte. So now this 7 requires, sorry, H, A and space can be easily represented in 1 byte of memory. Am I right or wrong? That means for first 127 characters in UTF-8 will be given with 1 byte of memory. Will be 1 byte of memory. Are you guys following what I am saying? It requires how many bytes of memory? 1 byte of memory. So when compares to UTF-16 to UTF-8, does we optimize the memory further? We had optimized it, correct? Because in UTF-16, H, A and space are still taking 16 bits. But when comes to UTF-8, which really required only 1 byte. So that means for first 127 characters, it will allocate only 1 byte, as simple as it is. Okay. So now the example is A over here, like which is 41, like 01000001 is a representation of character A in the binary. Correct? This is the representation, correct? Am I right or wrong? If you take 67 and do our calculation, what we discussed, conversion from the decimal to binary, it will look like this. It is 10000001. So which is represented as 0041 in hexadecimal, which is represented as 0041 in hexadecimal. So now the least significant, which is 1 takes the first 4, that means it takes 4, and this takes 4 basically. That's what it is. This takes 4 and this requires 3, and this is a padding value of 0, as simple as it is. Okay. So you require 4, this 3 and this is 0. So first 127 require only 7 bits. Am I right or wrong? Now, does this fit? Does your poop emoji fits into this 7 bits? Doesn't fit, correct? Now what should we need to do for this? That's the question. So that's where we have a case 2. So any number that falls in between 128 and 2047 has to follow this process, as simple as it is. Anything that falls in between 128 and 2047 has to follow this. 0 to 127 straightforward, only 1 byte, 8-bit representation. But anything that falls in between 128 and 2047 has to follow this process. So for the first byte, you will have 2 bytes still. You require 2 bytes to represent anything that falls in between 128 and 2047. In the first byte, these 3 bits are static. That means 1110 will always be there. And the second byte, these 2 bits are static. That means you will always have 1, 0. Now what you need to do is, let's take N symbol, N sign. You know N, correct? N is Japanese currency. So that is 165. The code point, that is the decimal number for the N in the Unicode, is 165. Now, is this falling in between 128 and 2047? Yes, it is falling in between that. So that means it is eligible for the case 2. So now, convert the 165 into 8-bit representation. So 1 bit, so in 8-bit representation, 165, if you follow our calculation, it will be 1010100101. Now pad until it reaches 11 bits. That means how many bits we have over here? 8 bits, correct? 11 minus 3 is, 11 minus 8 is 3. That means you still have 3 bits. That means you just need to pad with zeros, as simple as it is. That means you need to add 0, 0, 0 in front of this. 3 zeros in front of this. So you need to add 3 zeros in front of this. That's called padding. We discussed about this already, correct? So you just need to add zeros. Now take first 5 bits from this 11 bits. First 5 bits is 0, 0, 0, 0, 0, 0, 1. Take 5 bits and put this 5 bits into this. 0, 0, 0, 1, 0. Okay. Now you have how many bits remaining? 11 minus 5? 6 bits, correct? Those are 1, 0, 0, 1, 0, 0, 1, 0, 1. Now take this 6 bits, put it over here in the empty spaces of this. It will be 1, 0, 0, 1, 0, 1. Are you guys following me? So any number that falls in between 128 and 2047 has to follow this process. So that means anything that falls in between these two numbers requires how many bytes? 2 bytes. Are you guys following me? So this is how you convert. So you have first byte, second byte, first 3 bits are static. That means they will never change. Always it will be 110, always it will be 10. As simple as it is. But rest calculation follows like this. So take that, convert into binary, pad it until 11 bits. That means if it is only 2 bits, if you take 1, it is going to be 0, 1, correct? How many how many more bits you need to pad it with 0? 9 bits, correct? Of course 10, correct? Because 1 is 1, that's it. 0 is still doesn't have any value. This is just 1, correct? So 10 bits you need to pad it with zeros. No, 1 is 1. You need to pad that with zeros, correct? Until it reaches 11 bits. So this is how you convert, as simple as it is. Isn't it simple, guys? This is what your computer does internally to represent the values. If you have a symbol n, you are typing a character n on your keyboard, which is of number 165, and that has been converted like this internally. Isn't it efficient? So anything that falls in 0, 127, 1 byte. Anything that falls in between 128 and 2047 requires 2 bytes. And what about the other cases? Let's look at it. Anything that falls in between 2048 and 65535, that is 16-bit representation. 65535 is 16-bit representation. That requires how many bytes? 3 bytes. And this is how the 3 bytes looks like. So first byte, first 4 will be static. They are constants. That means it will be 1110. And second byte, first 2 bits will be constants, that is 10. And third byte, again, first 2 bits will be constant, that is 1 and 0. Now, let's take one character. Let's take a code point which is 65515. 65515. Is it falling in this range? Yes. So convert this into a binary. It looks like this. Pad until 16 bits now. There in the second step, pad until 11 bits. Here in pad until, we don't need to do padding because it's already 16 bits. It's already 16 bits. You don't have any empty spaces, correct? To pad with zeros. So it's already 16 bits. Now take first 4 bits and put it into this empty spaces. Now take the next 6 bits and put it into this empty spaces. Now take next 6 bits and put it into empty spaces. Are you guys following me? This is how computer does. This is what the computer do internally. To represent a character that falls in between 2048 and 65535, it exactly follows this calculation. With UTF-8 encoding, you need to remember this. All your programming languages will use UTF-8 encoding only. Okay? You have to specify if you want UTF-16 or UTF-32, you have to specify that clearly. But by default, it is UTF-8. Any program that you write and execute, that's UTF-8 by default. It uses UTF-8 encoding by default. Are you guys following me? Same way with case 4. Any character that falls in between 65536 and 111411. This is the maximum Unicode character at this moment in time. It requires how many bytes? 4 bytes. Byte 1, byte 2, byte 3, byte 4. So byte 1, first 5 positions are static. Byte 2, next first 2 positions are static. These are 2 static, these are 2 static. Now take the number and check whether it falls in this range or not. Then convert that into a binary, pad by 17 bits. Pad it by 17 bits. Sorry, 21 bits, not 17 bits. 21 bits. If you convert this, it will be 17 bits. How many bits you need to pad with? How many more bits you need to pad with? 3, correct? 21, 4, sorry. Yeah. That means 21 minus 17 is going to be 4. So you just need to pad with 4 bits. Now, first take 3 bits and put it into this empty spaces. And then you take the next 6 bits, put it into this empty spaces. Next take 6 bits, put it into this empty spaces. Next take 6 bits, put it into this empty spaces. That means anything that falls in between this number and this number requires how many bytes of memory? 4 bytes of memory. Isn't it efficient? It is efficient, correct? So based on the range that the symbols, decimal number or hexadecimal number falls in, you are allocating that many number of bits to it or bytes to it. Okay? So the last words, the last thoughts, 1 byte decimal range is 0 to 127. That means any number that falls in between 0 to 127 requires 7 bits, which is an ASCII characters, correct? ASCII symbols. 0 will be padded, next 7 bits will be used. Now 2 bytes, anything that falls in between this range, 11 bits padding, first byte and second byte will be used because it requires 2 bytes. In the same way, anything that falls in between this range requires 16 bit, it requires 3 bytes. Anything that falls in between this number to this number requires 4 bytes. Isn't it efficient? How much memory are we really storing? Saving. It's really optimized, correct? So you look at 32-bit, 16-bit and 8-bit, which is more optimized? UTF-8 or 16 or 32? UTF-8 is more optimized. This is one of the interview questions that is asked in Google. You don't have UTF-4 because 1 byte is 8 bits, correct? You cannot go further granular. You have other encodings which works more efficiently based on the scenario. If you take machine learning algorithms and all, they have their own encodings, like 16 floating point numbers, 16 byte encoding, BF16. There are lots of encoding techniques, but this is a standard encoding technique that has been used across your modern computers. Is it clear? So, yeah, this is what it is. We already discussed about all these things. This is what it is, guys. Is it clear? Very important interview question. If you are going for Google, Facebook, or if you are targeting some product companies, they expect these things from you. What is the difference between UTF-32, UTF-16, UTF-8? Exactly. Which is more efficient? So you should be in a position to answer to all those questions. Even when you write a program, if you keep all these things in your mind, you will write it so beautifully, correct? Am I right or wrong? That's the whole idea of taking this session.